Today, we're going to be reviewing some concepts about IPv6 as a final adaptation to the public network shortage. But before we get into that, we want to circle back around and revisit using CIDR to segment. This is due by 2 p.m. Friday. Now I'm going to go ahead and change this to 5 p.m. We'll give you to the end of the day. And then the solution, we're going to bump back to Monday, 1 p.m. What we'll do is walk through the specifics for each of these, the 3.2 assignment and the 3.3 solution before we take up IPv6. Were there any questions or issues yet with the 3.1 assignment? So if you would, in your Blackboard, you'll notice in resources, there is a folder called assignment and solution tasks. And when you come into here, you'll see CIDR templates. And what I want you to do to complete the 3.2 assignment is to download a copy of each of these CIDR templates, classless internet domain routing templates. Okay, all 6 of them. Now you won't use these very often. These are much larger templates, and you'll find out that when you take a standard Class C subnet with 256 addresses, and then you ratchet down from 24 to 25, 26, 27, 28, 29, 30, you're cutting in half 128 usable addresses, 64 usable addresses, 32 usable addresses, 16 usable addresses, 8 usable addresses, and 4 usable addresses. We chop in half as we increase the subnet mask, we decrease by half the number of usable addresses. So /24 has 256 addresses, 3 are used for network identity, gateway, and broadcast. So there's 253 usable addresses. But the total number of addresses is 256 for a /24. The total number of addresses available, 128, 64, 32, 16, 8, and 4. Any questions about what I just related with respect to the increasing subnet mask, the increasing number of ones? Okay. So what do you do with the assignment? Well, the assignment is a pretty simple activity. And if you look at the assignment, here is segmented networks, right? Can everybody see the screen?
Yes.
Yeah.
Okay. Glad you could join us. For those of you that are joining us in progress, we'll update our roster here. So we just walked through inside the resources folder is a folder called assignment and solution tasks. Inside that is a folder called CIDR templates. You have these CIDR templates to use for CIDR solutions, for selected CIDR solutions when you're going from a larger to a smaller subnet. Now, what you're going to find soon is that when you go in the reverse direction, it's a little more complicated, but we'll talk about that in a minute. For your 3.2 assignment, you are going to want to download a copy of each of these for use with the 3.2 assignment. Good afternoon, LaQuinn.
Good afternoon, Dr. Kentap. How are you?
Good. We're recording this and your timing is good. So once you get these templates downloaded, You're gonna open this document for the 3.2.
I did the assignment, I don't know. I don't know if I did right or so.
We're gonna do the first one together, LaQuinn. And I'm glad you're bringing this up. That's so your timing is impeccable. I appreciate you speaking up. Okay. So what we have is a case where we have several problems and you're supposed to use the CIDR templates in order to calculate the answer for each of these. And you got to understand the size of a typical Class C network is reduced by 1/4 its original size. So what are we saying? We started off with a /24 network. And when we're using CIDR to efficiently allocate smaller segmented networks, and that's the focus today. We're not using CIDR to build larger segmented networks. We'll talk about that on Monday. We want you to get a handle on how this works when you're using a large address range and you want to break it up into smaller, more efficient allocations of usable public network addresses. This is what people are doing in internet service providers right now as we speak to make sure that their customers continue to have a good internet connection, right? So if you have a client that's sitting on 196.217.86.115, and it's a /24 network, and you have an internet service provider that has to figure out, okay, now I need to build more networks, and I have this one network. If you do the operations we've already learned, a /24 means these 3 octets are used to identify the network, and we replace the last octet with 0. So the network identity for this is 196.217.86.0/24. Can anyone tell me what the typical gateway address would be for this network? What would we use normally for a gateway address for the 196.217.86.0 network?
Would it be the .1?
It would be the .1. Thank you so much. We would add 1 to the network ID. If we want to know the broadcast address, all we do is max out the last number, 255. So the broadcast address is 196.217.86.255. That's what we do if we want to know what the broadcast address for every connected device on that network is. But when we're using CIDR, we're trying to become more efficient at managing our networks. And we can use one public IP address to connect many devices if we use NAT correctly. So what we want to do is segment the network, break it into smaller networks. So if we increase the subnet mask 2 places to the right, if we slide the subnet mask 2 places to the right, what we're doing is adding 2 more 1s. Whenever we slide to the right, we're adding 1s. And if it's 2 places to the right, we're adding 2 to 24 1s, which means that we now have 26 1s. 2 to the 2 place is 4. And if we flip that, we get 4 networks. Each of those 4 networks are 1/4 in the original size of the Class C network. What are we saying? We take this number, 196.217.86. I'm actually going to copy this. Okay. I'm going to go ahead and copy this. And then I'm going to go and get my CIDR template. Okay. So I'm going to go back to, should have CIDR templates. /26. There's my /26 net template. Where do you get yours? Right here, you download it. It's an Excel spreadsheet. When you download it, this is what you're going to see. You're going to see this basic framework that helps you break out the 4 networks. So we're going to create 4 networks that are 1/4 the size of the original network. And here's the thing I want you to understand. We just yep. Well, okay, let's do it this way. It's being stubborn. Okay. I think because we have the dot, it's trying to put in 2 sets of decimals, and we're doing this in an Excel spreadsheet. So just bear with me here. Nuts. There we go. It's being stubborn. Can everybody see this?
Yeah, I can see it.
Yes.
So let's go back to our problem. We're dealing with a network that is a 196.217.86.115 network. And from the subnet mask, we know that the .0/24 is the network identity. So in our spreadsheet, just to remember, we could do this just so we understand the context. Okay, I have a Class C public address network, and that Class C public address network is 196.217.86.0. I have 256 addresses originally, but when I increase the /24 subnet to a /26, the mask increase is 2 binary values of 1. So I have 26 ones in a row instead of 24 ones in a row. The number of networks I can create with that traditional Class C network, I can create 4 new networks. So if I had 4 big customers, I had 1 network, but I have like 2 big customers, and I got to make room for those 2 big customers. And then I have my original customers, so that's a 3rd network. And then I have new customers, that's a 4th network. I could split my original network of 256 into 4 if I were an internet service provider and I were planning, right? Now, the CIDR multiple is 64. What do we mean by that? When we look at the number of usable addresses or total number of addresses, we have 64 possible addresses. We have to reserve an address for the network identity for each of those 4 networks. We have 4 networks now instead of 1. Each one has to have a network ID. So the second network has a network ID of 196.217.80.64. This represents the start.
86. You said 8086.
I said what now?
You said 80. It's 86.
It's 86. My bad. Okay. 86. Thank you. Didn't intend to do that. 86.64, that's if it's a /26, right? So what's my new network ID for network number 2? 196.217.86.64/26. That's my new network identity. Now, what is the gateway for that network number 2? Well, it's one more than the network identity. If the network identity is .64, the gateway is .65, right? Now, my last highest number is the broadcast. I have these other addresses in between. So the range of usable addresses for network connected hosts, I would have 61 usable addresses. If I count 66, 67, 68, 69, 70, 71, all the way to 126, you'd find that I have 61 usable addresses in my network, my second network, okay? And the broadcast address is 192.217.86.127, right here. Now, what about the third network? The network identity for the third network is
128.
128. Okay. That's my third network. So I've taken a single class C network, which was originally 196.217.86.0, and I was wasting addresses. And I needed to create smaller, more tightly managed, segmented, meaning divided, separated, smaller, more secure networks so that I can make better use of them with customers, right? So that's what I'm doing in the first example. So when I look at this answer, it says using the IP address and the criteria provided, determine which network ID, gateway, broadcast address, and the number of usable IP addresses remaining in the subnet are available for network clients. So how would I answer this question? We get back to this answer right here. See, to answer the network where this client is now going to reside, okay, using the IP address and the criteria provided, this is the original client address, 115. Now, how do you figure out which network 115 is a part of? LeQuinn, this is where we come full circle. Which network? Here's the first usable address and the last usable address. In network 1, the first usable address is 2 and the last usable network address is 62. But we have a client that uses 115. Which of these networks, 1, 2, 3, or 4, has a range of usable addresses where 115 fits in?
Second one.
That is correct.
Mm.
That is correct. 115.
Mm,
115 fits between 115 fits between the first usable address and the last usable address. So then what do we put for our answer? Well, we say the network ID is 196.217.86.64/26, because we've got a different subnet mask now. What's the gateway address? 192.217.86.65. What's the broadcast address? 196.217.86.127. And that's what we type into this one. This is where we put the answer right here. We'd say, okay, the network ID. Right, so we're given this host. This is the host we have to work with. And we got to come up with all the rest of that information, right? So then we type that out. We say, okay, net ID 196.217.86, whoops, .64 slash, it's no longer a 20, it's not a 24, it's a 26, right? Gateway 196.217. You understand what I'm saying now? So I'm referencing this template. These templates will help you no matter what you're doing. If you're breaking bigger networks into smaller networks, you can use these to get all the information you need. Now, you can do this the hard school way, and there are all sorts of great YouTubes about how to calculate this manually. You are welcome to learn how to do that. In the Cisco Net Academy, they have a method that you can use to calculate all that manually. And you can learn that method. But it works the same all the time. So my thing is, why don't we just have a set of standard values that we calculate so there's no mistakes and we all work off the same page so that we have consistent results. The problem is that when everybody learns 12 ways of manually calculating these things, sometimes the answers are right and sometimes they are wrong. All right, I need to pause for just a second. Please hold. Hello, I'm back. Okay, so can everybody see my screen?
Yes.
All right, so let's take the next example. I just want to take the next example on the worksheet. Of course, you would fill out the rest of this stuff here. Problem number 2. I have a 208.43.195.115 network. Now I'm doing the same kind of thing. I have the same host address and I have the same subnet mask to start with. But this time, instead of sliding the subnet mask 2 places to the right, I'm sliding them 4 places to the right. I am adding 4 ones to the 24 ones that exist in the current subnet mask. And what that's going to do is it's going to create 16. 2 to the 4th is 16. 2 to the 2 is 4. But 2 to the 4th is 16. I'm going to create 16 smaller subnets. Segmented networks. More easily manageable networks. More easily defended networks. More easily monitored networks. Okay? So in terms of just sheer management and security, I'm going to have a better result all around. So I'm going to increase this subnet mask and I'm going to get 16 different neighborhoods, network neighborhoods to work with instead of just 4, right? So now that we have a /28, the size of a typical Class C network is reduced. Well, if I have 16 of those, if I take an original one and I break it into 16, 2 to the 4th is 16, that means each of the smaller networks is 1/16 its original size. Does everybody understand what I'm saying?
Yeah.
This template, the /26 template, doesn't do me any good. What I need instead is the /28 template. Oh my goodness. So instead of having 4 networks, now I have 16 networks, right? So everybody with me? Can everybody see the screen?
Yes.
Okay. So question. If my original host address is 115, which of the usable addresses would host the 115 address? Which network? Which network number? Network number 8 is correct. So, I mean, I can do a lot of fancy calculations. I can learn 6 different ways of doing binary math in your head and all these YouTube videos. But if I understand how segmenting a network is supposed to happen, and I understand classless internet domain routing, I can have these lookup tables. The trick is I have to be able to substitute the original network values when I give my answers. So I know the network ID is 112. That means when I give my answer, I'm going to say the network, I know it's network number 8, which is net ID 208.43.195. What did we say? We said network 8. Oh, it's 112. 112 slash, what's my subnet mask now? Oh, it's 28. So that's my network identity. I've just identified what network 8 is. What's my next address available so I know what my gateway is? What's the next one after 112? Anybody?
113.
Uh-huh. Now, do I want you to type out the entire IP address? Well, it's best practice. It's considered good form. But for the purposes of this solution, this assignment, and your ability to break down networks into smaller networks using CIDR, I don't care if you use shorthand. You could say, when you fill out your worksheet, gateway GW equals 113. And then you could say something like bcast for broadcast equals, well, let's see, what is broadcast for network 8? The last one in the range is 127. Everybody see that? 127. Now we understand that the first part of this is 208.43.195. So I can just copy this, paste it. Now I have my complete answers. So we've just walked through problems 1, 2, and 3. I mean, just problems 1 and 2. I want you to do 3 and 4 on your own. Okay? I want you to do 3 and 4 on your own. I'm going to use a /25 template. I'm going to use a /30 template. I'm going to do the same thing. Oh, I got to look up where 166.
Quick question, Professor Kentop. For
Yes.
problem 2, the usable IP addresses would be 13.
That is correct.
Okay,
That's a great question. And how do you confirm that?
I use the chart.
You can use the chart and say possible hosts supported is 13. You have 16 addresses, but you have to always designate the network ID, the gateway, and the broadcast for each network, which means you have to use 3 addresses out of 16. So the 13 is what's left. That's why I love these charts. And after 20 years of working in networking and going over 16 different ways to calculate in your head how to do this stuff, I'm like, you know what? It's pretty crazy to do it the one way. Now, what about in the other way? Let's talk about the other direction. Okay, we have two problems, 5 and 6. And this is where you go in the other direction. Instead of sliding the subnet mask to the right, we're going to slide it 2 places to the left. So we're starting with a /16 and we're creating a larger subnet mask. Now this is not as common, so we don't take as much time focusing on this. Can you use the same getup that you do here with tables? Yeah, but the tables aren't as handy that way. The way you have to structure the lookup tables is a little different and a little awkward by comparison. So what to do? You should always use stuff like this on the internet, because when you create a larger subnet, technically speaking, when you take smaller subnets and you fold them together, what you're really creating is a supernet. Everyone, repite usted, por favor. Supernet.
Supernet.
Yeah, so when you're making larger ones, if you're going smaller, we're doing network segmenting. If we're folding adjacent smaller networks into a larger network, because we want to manage the allocation in a different manner. And again, once again, really not common. Then what you do is you take the information you're provided and you go to Jodi's.de IP calc. Now the .de means Deutschland, right? So this is a German engineer who came up with this website, and it's actually a brilliant website. So all I'm going to do is control click this, and we're going to go here together. And can everybody see my screen?
Yes.
Yes.
Okay, so this is really cool stuff, right? And what we're doing, you can read all of this and how it works, but if you come down here, basically it's a pretty simple thing, right? So let's say I have a certain address, and then I have a certain subnet mask, and then I start with a 24 and I'm moving it to the larger or smaller. So you can use this, you can also use this website to go smaller. What I'm going to do is show you how to use it with the first one, right? So if I get this, let's say I have this IP address. Everybody with me so far?
Yes.
And I'm going to put it in my notepad first because I want to wash the formatting and font and characters out of here before I push it into the website. So that's my IP address. I'm going to go into here and I'm going to paste this in here. Is my subnet mask a 24? No, it's a 16. So everybody see that? So I'm going to change this to a 16. Is everybody with me so far?
Yes.
Yes.
Okay, now I'm moving to a /14. I'm going to the left instead of the right, and I'm going 2 places. 2 to the second is 4. It's quadruple the size. I'm quadrupling the original size of that network. So I had 65,536 total addresses. Wow. And now I'm gonna like quadruple the size. Well, what happens when you quadruple 65,536? You get like 250,000 addresses, right? Let's see what happens. I'm going to move to a /14 and I calculate. Now this is going to change down here, and it's really important to understand. It's really important to understand. Can everybody see this information right here?
Mm-hmm.
This information right here. Okay. What you need to know is that you got to take this address and you got to figure out where it fits, okay? So the original was 135.217.86.155. That means the network address was, if I take a /16, this is the host address, this is the network identity. This all makes sense for what we've learned so far. The network identity in the original network for a /16 was 135.217.0.0/16. Gateway would be .0.1. Broadcast would be 255.255. I'm going to fill in any of the octets that have zeros with 255s, and that's going to give me my broadcast address. So this stays the same, but it's 0.0 for the network identity and 255.255 for the broadcast. The minimum value for a host is 0.1, but we know we're going to use .1 for our gateway. Let me repeat that. With this tool, the thing you got to remember is it's not telling you about a gateway. But the gateway is the first usable address, the host minimum address. .1 in this case. Now, look at the number of hosts, 65,534 possible hosts, including the gateway address. So if I subtract the gateway out of there, it's actually 65,533. Does everybody understand what I'm saying? Kind of, sort of, maybe. I chopped 2 ones off of the 255 here. So instead of having 8 addresses, instead of having 8 ones right here,
Professor Kantap, is that you glitching out or is that me? I can't tell.
Huh?
It sounds like you're glitching out for me.
It sounds like what? Is the audio bad or something? All right, if I increase by 14 to 14, what I've done is change the network identity. Look at how the network identity changes. The network ID is 135.216.0.0/14. Okay. The broadcast address is 135.219.255.255. See, that's like 2 more higher than the 217 we started with. Everybody see that? We've quadrupled the size of the network. My gateway address is 135.216.0.1. And I can host 262,142 network hosts. Okay. And just remember that my broadcast and my network ID are going to be different. They're going to be considerably lower than my original, right? So this says 216 instead of 217. And then my broadcast, instead of being 217, it says it's 219, right? And so this website is actually pretty good about supernetting. It's better to use for supernetting. So all you got to do is put the information in here and then click calculate. Any questions on how to use this? So how would I answer the first question? I would say my network ID is, right? Say network ID. Then I'd say gateway is equal to 1 more than that. So I can actually do this, and then I can just put a .1. Did you ever see how I did that? And then the broadcast equals, broadcast is, wow, it's not in the 216 range at all, right? Because I've got a supernet now that's 4 times as big. So it's going to use a 219.255.255 instead of a 216. It's quadrupled in its original size. But that's the information I need to complete problem number 5. I need you to complete problems 3 and 4 on your own. And I want you to complete problem 6 on your own. Just finish what we've demonstrated here in class, okay? Any questions about 3.2 assignment?
I've done problem 3 and 4, 3, 4, and 6 already.
Excellent.
Yeah.
Outstanding. Now, what's going to happen is you're going to post that solution. You're going to post your answers. And then I'm going to post the answer key. I am not going to grade your assignments. I'm going to provide you with the answer key that has the answers. And then you're going to compare your own results with the answer key. Once you look at the answer key, right? So I'm going to go ahead and extend the assignment deadline because I want you to have more time. Let's say 11:59 p.m. tonight, okay? Everybody good with that?
Mm-hmm.
So I want you to do this while it's fresh. Everybody, you got to do this while it's fresh. Quick.
I have a question, Professor, about this solution.
Yeah, I'm about to get to that. And
Okay.
in the last 2 minutes, I want to talk about the solution, okay?
Okay.
Okay, so the solution that you're going to perform is due by 1 p.m. on Monday. And the very coolest part of this is the helpful tips section. Now, this is really, really important. Can everybody see my screen?
Yes.
Okay, now I updated this helpful tips this morning. Can everyone see this information and can you see your own name on the screen?
Yes.
Okay.
Yeah.
Now, I'm going to show a video at the top. It says, hey, first watch this video. So when you click that link, this is what you see. Okay, it walks you through how to do this. Now, instead of showing a .13, it shows a .9. So it's a little different, but the process is the same. And what happens is that you create a network with 2 routers, 2 switches, and 2 endpoints, 2 PCs, okay? Can everybody see the networks here?
Yes.
Okay, so when I demonstrated this, I used a .9 address. Notice the 9, 192.168 dot what? 9.0. What about the network between the 2 routers? 10.10 dot what? 9.0. What about this network over here? 172.16 dot what? 9. So who's actually doing that, right? Who is actually working that? Well, in this case, the .9 network is done by Khalil Smith. Okay. So what is it you're actually doing for this walkthrough? When you watch this, in 20 minutes, you'll know how to do all of this. Okay, you're going to drag 2 PCs, 2 switches, 2 routers. You're going to create one network for the first PC, another network for the second PC. Oh, then you're going to create a third network that connects the 2 routers out here on the internet. Let's pretend that this is like the backbone. So these are local networks that are isolated from each other and they're distinctly different. This one's a class C network. This one's a class B network. This one's a class A network. They're all internal private networks. But this one's like the backbone network. It connects all the different routers that are strung together like Christmas tree lights. And each of those are like gateways into their own little network pond, okay? Is everybody with me?
Yes.
Now the goal is, when you set up the routes correctly between these two routers, this PC will be able to talk to and ping this PC, and this PC will be able to talk to and ping this PC. What you're going to see is how you can have segmented different networks, smaller ones, each uniquely different, and using a router and routes, you can create a beautiful, secure, resilient, redundant set of networks or internets. Oh, hey, that sounds familiar. Internetworks. That would be like, what's the biggest of them all? The internet, the global internet, right? This is the basis of how our internet is built. I want you to watch this 20-minute video more than once. Then I want you to open up your packet tracer and just follow step by step. Just do exactly what I'm doing. The only difference is I don't want you to use the same values I use, with the one exception. We've already said that Khalil will be using the .9. Now, I can demonstrate this on Monday in class. I'll use the .13. And if you want, I can demonstrate it live on Monday. But each of you are going to use your own network. So Chaz is going to have network 1. He's going to use .1 for each of those separate networks. So as you watch the video, Chaz, are you with us, Chaz? You still there, Chaz? Okay, your microphone is muted. Maybe you're saying yes. Chmira is going to be using the .2. So the second network is going to be built by Chmira, and you're going to use Packet Tracer on your own laptop. And when you set up your own arrangement, you're going to be using .2, not .9 like in the video, but .2. James, you're going to use .3, .3, .3. Okay. Jadel, .4, .4, .4. Everybody see what I'm talking about? Joel?
Yeah.
.5, .5, .5. Now, why are we doing this? Believe it or not, the first year we had this hands-on thing, we did have a student or two that decided to watch my video, capture the screens from my video, and try to submit those as if it was their own work from my video. Which is why everybody has their own set of networks to do now. Okay? So if I see anyone with a .9 solution, and it's not Khalil, I'm going to be asking a lot of tough questions, right? Or if I do this on Monday and you happen to be capturing screenshots, if I see .13 in your submission, I'm going to be asking, okay, what gives? Why do you have, why do you have the same screen that I have? Suleiman, you're supposed to be on .14. Omeyer, you're supposed to be on .12. Your solution will show your numbers, okay? And no one else's. So LaQuinn, you have .10. Kevin Monsanto has 8 across the board. Kareem, you have 7. Does everybody understand what we're doing?
Yes, sir.
Okay,
Yeah.
well, unless there are other questions, I'm going to go ahead and close out for the day. I wish you a delightful weekend. While the trail is fresh, go ahead and complete the subnetting activity, the subnetting assignment for 3.2, and then watch those videos over the weekend and give it a shot on Monday morning or Saturday afternoon. It's not hard. All you got to do is watch and follow, and then
I already submitted mine yesterday.
oh, okay, well, that's cool. Excellent. Now the thing is, the helpful hints was different yesterday. So if you did yours, but you didn't use your specific IP address, you can,
Yeah, I
Yeah.
have to do it again.
well, all you gotta do is open your stuff up and make the changes to the numbers, right?
Yeah, it's not no big change.
It's not a big change. And then just show the different results, right? So that's what I love about this. You can adapt very easily. Okay. Any other questions or issues before we clear?
So for this solution, we have to get done by 1 o'clock on Monday.
Ideally,
Before, sorry.
yes. We want
Okay.
everybody to
So I
try to-
thought we'd have been going over it, and then after that again. But then we already did it today, so yeah, that makes no sense.
Okay. All righty. Have fun with it. If you want to, for extra credit, you can actually add a third leg of the network and have a totally different network on either side and get them to work. There's just one trick to the routes. And if you're used to setting up this first set of routes and you think about it at all, you'll be like, oh, I know how to set up that set of routes so that each of the 3 PCs can still talk to each other, right? So when you add another layer, you just gotta adjust the way the routes are. If you can figure that on your own, you get buku, generous amount of extra credit. But you don't have to do that. You don't have to do an extra leg if you don't want to. All right. Take care. Have a great weekend. We're going to sign off for now.
All right, see ya.